Now, another exercise 3A question 19 example. Solve for negative pi less than or equal to x less than or equal to pi. Yes, we've got to change domain, but this time it's not 2 times or 3 times or whatever. We've got a shifted sort of domain. So what I do, I don't want the domain for x. I want the domain for x minus pi on 6. So if you're comparing what's up there to what's down here, what happened to the x? We subtracted pi on 6. So you just subtract pi on 6 from everywhere. Yeah, we will, but I'd be very careful. So minus 1 minus 1/6 is what? Minus 7 pi on 6 less than or equal to x minus pi on 6 less than or equal to 5 pi on 6. So that's our new domain. All right. Just got to make sure our answers fit in there. That's all. Okay. So, still the same methods. What quadrants are we working in? And what's the acute angle for all of that? You just take it as all of it. So quadrants what? Sine of that is positive. So quadrants 1 and 2. Next step, acute angle, not x, but x minus pi on 6. See, because you're saying to yourself, sine of that whole thing is 1 on root 2. Sine of what? Good. Sine of 45, which is pi on 4. Next step, we draw it. So girls, they're all still done the same. But instead of saying sine of x is whatever, acute angle x, it's acute angle of that whole thing. Acute angle of the whole 2x is that. We then draw our quadrants with pi on 4 in them. And we don't work out x straight away. We just know that x minus pi on 6 is in these two quadrants. And what do I get? What do I get? Pi on 4 is my quadrant 1 result. And 3 pi on 4. Now, let's just make sure that I can't get one of those results another way. So remember, I've got minus pi to pi, which became minus 7 pi on 6 to that. So actually what I should be doing, girls, I've been a bit naughty, I should be going from 0 to 5 pi on 6 and searching for any solutions I can find there. So this is definitely, look, 5 pi on 6 is further, 5/6 is bigger than 3/4. So that solution fits in there. See, 5 pi on 6 is here, and minus 7 pi on 6 is there. When you come the negative way around, from 0 to minus 7 pi on 6, I don't get any solutions. Well, if you think this might be one, wouldn't that be minus 5 pi on 4? And that is negative 1 1/4 is bigger in magnitude than negative 1 1/6. See, girls, look, 5 pi on 6 is there. I go 0 to 5 pi on 6, and I come back, and I go 0 to minus 7 pi on 6, which is there. This does not, I don't see a solution on my way back. Because it's over here. All right, what's pi on 6? I'll show you why. Pi on 6 is 30. No. Yeah, because it's positive. Here are my two solutions, 30 and 30. They're my two solutions. 30 and 1 pi on 6. That's 30. Yeah. No, pi on 4. That's, sorry. What is wrong? Yes, I know it's that. Sorry, I'm drawing in my domain. I'm drawing my domain in. That's my domain. From there to there. So can everyone just look again? I'm drawing not my solutions, but my domain. My domain is from there to there. Stop. Start from here again, from there to there. Do you see that? Because the domain is up to 5 pi on 6, which is 150, and to negative 210. Now, let me draw in my solutions. But my solutions are 45 there, 45 there. Do you know what I mean? So you get the two solutions here, but on the way back you get none of them. Oh, I should have done them in different colours. Do you see it? Now I add pi on 6 to both of these. And that's when you get your calculator out. 1/4 plus 1/6 and 3/4 plus 1/6. Unless you want to go times 3 times 2, 5 pi on 12. And times 3 times 2, 9, 11. 11 pi on 12. So it's easier just to go 1/4 plus 1/6, 3/4 plus 1/6. 5 pi on 12, 11 pi on 12. Now, if you want, get your calculator out, go sine in radians, bracket, 5 pi on 12 minus pi on 6 close bracket, and you should get -1 on root. Here's our second example. Cosec x plus pi on 4 equals -√2. Oh, the domain is from, in the question, is from -pi less than or equal to x less than or equal to pi. So, of course, we have to change it to x plus pi on 4. So what do we do when we add pi on 4 to each to that? You get 1 1/4 pi. And what's -1 plus 1/4? -3 pi on 4 is our shifted domain. So let's change our question as well. Actually, instead of writing that, why don't I write that sine of x plus pi on 4 is -1 on √2? If cosec of something is √2, then sine is 1 on √2. Well, you could write it like this, and then all you do is swap that with that. Yeah. Swap across the diagonal. So therefore, sine of x plus pi on 4 is -1 on √2. So what you would do, if cosec is √2, sine is 1 on √2. It's the reciprocal. 1 minute. Sorry, I think I stopped recording somewhere there. So therefore, sine of x plus pi on 4, swapping those, is -1 on √2. So our quadrants are 3 and 4, and our acute angle, sine of, we know 45 is 1 on √2. So acute angle x plus pi on 4 is pi on 4. Now we really need to look at our domain here, otherwise we're going to miss some solutions. My domain is telling me I'm going from 0 to 5 pi on 4, and then I'm going from 0 to -3 pi on 4. So this actually happens to be the border as well as the solution. Because look, 0, pi, so it just made it. So 0, pi, here's 5 pi on 4, and it's actually my solution because I'm looking for quadrant 3. So my first solution for x plus pi on 4 is 5 pi on 4. Now I have to stop going this way, and now I come back this way from 0 to, where's -3/4 pi? It's there as well. So I add it again as another solution. So going back, no, I've got -pi on 4, and what else? And -3 pi on 4. So that's the border, but that border of where you're going around stopping, so going around stop here is 5 pi on 4. Stop, go around, 5 pi on 4 is the same as -3 pi on 4, same position. But that actually happens to be where one of my solutions is. So now what do I do? X is, subtract pi on 4, don't I? I need to get x on its own. Therefore, x is 5 pi on 4 minus pi on 4, -pi on 4 minus pi on 4, and -3 pi on 4 minus pi on 4, which is pi, -2 pi on 4, which is -pi on 2, and -pi. And notice it fits in the original domain. Pi and -pi are on the borders of the original domain.
Oh, that was It excites me when the angle makes the cut.
So when you've got your final answer, when the final answer is in terms of x, if you make sure that these answers fit into the changed domain, see, some people don't get it right here. They just keep doing extras, and they get more answers down here as long as you're cutting them off at the end. So let's say you decided to do more answers either side, and you got it wrong. Doesn't matter. As long as when you come down to the final row, You double check that you're in the original domain. See, now I'm back in terms of x. As long as you're lying between negative pi and pi, you're okay. So if I did do additional solutions, I could, as long as I cross them off and say out of domain. Last question here. Solve 4 cos squared theta plus 2 sine theta equals 3 for the domain 0 through to 2 pi. What are we going to do? Remember not double angle results. It's still 2-unit work. It's giving you a hint. Replace cos squared theta with. So 1 minus sine squared theta. All right. What are you going to do? See, when you're solving equations, what are you going to do now? Yeah, you're going to expand. You're going to take everything to the left. Group-like terms and whatever you've got to do. So you've got 4 minus 4 sine squared theta plus 2 sine theta. What do I do with the 3? Minus 3. Now what have I got? Yeah, let's take everything over. There's nothing worse than a negative squared term. Everything's going to the right now. 4 sine squared theta minus 2 sine theta. Now I've really got 1 on the left, so it'll become minus 1 on the right.
Isn't it?
Factorize it. Have to use quadratic formula. Sine theta is in place of your x. So sine theta equals negative b, which is 2, plus or minus the square root of b squared. What's b squared? Minus 4 times a, which is 4, times negative 1 over 2 times a, which is 4. So it's 2 plus or minus the square root of 4 plus 16. It's 4 minus 4 times negative 1. So it's 4 plus 16, which is 20 over 8. What are you going to do with square root of 20? Good. So 2 plus or minus 2 root 5 over 8. Now what are you going to do? You're going to divide. You can just think you can take out 2 as a common factor on the numerator, or you divide everything by. To make sure you don't mess it up, why don't we do that? Now it's 1 plus or minus root 5 over 4. So therefore sine theta is 1 plus root 5 over 4, or sine theta is 1 minus root 5 on 4. Now, have a look at those. Tell me, do you think 1 plus root 5 on 4 is positive or negative?
Positive.
Good. Quadrants what? 1 minus root 5. Well, root 5 is bigger than 2 because root 4 is 2. That's like 1 minus 2 point something. That's negative. What's this one? Positive or negative? Negative. Quadrants 3 and 4. So that's all you do. Now, it's like that question 10 of root 2 minus 1. Please, 1 plus root 5 on 4 is only a number. It's a decimal. It's irrational. So it's just shift sign of all of that. Gives you your acute. Oh, didn't we say we're going to do it in? Ooh. Do it in degrees so we can. I know it says to give your answer in radians, but please put it in degrees first because you can write the fraction radian form then. Oh, that's good. So therefore, acute angle theta is sine to the minus 1 of 1 plus root 5 on 4. And did you get an exact answer there? 54 degrees. So which is, in terms of radians, isn't it 54 pi on 180? 3 pi on 10. How nice is that? Beautiful. So let's do our solutions. Just up to 360, 0 to 2 pi west, 3/10. 3/10. Isn't that here somewhere? 3 pi on 10. It's 3/10. All right, so what have I got? What's quadrant 1 solution?
3 pi on 10.
And? Yeah, because it's 1 minus 3/10. Okay, this one. I know it's negative, but All right, this is what I need you to do. Oh, I think you'll get the quadrant. Yeah, but that's the quadrant 4 result, I'm pretty sure. Yeah, so look, I think, look, you know what I would do? I would do this in my calculator. 1 minus the square root of 5 over 4 equals, you get a negative answer. Then times that by -1 to get the positive answer, because when you put it in the calculator, you're not supposed to put the negative. Do you understand what I'm saying? So, is whatever, and then do the negative. Then I want shift sign. So what you want is shift sign of the negative of that. Do you know what I'm saying? Yeah. Because the negative is only to tell you the quadrants. What did you get? Good. So if you decide not to do that, just realise that the sign result, that -18 is your quadrant 4 result. So what's 18? Isn't that just pi on 10? Because it's 18 times pi on 180. It's pi on 10. So therefore you got pi on 10 in quadrant 3. Remember, these are the acute angles in the quadrants. You just draw them there. All right, so. But girls, we're doing 0 to 2 pi. So I don't want the negative, don't give you negative results. What do you got? I don't go backwards for these. What do you got? Good. 11 pi on 10 and, well, isn't 2 pi 20? Isn't 2 20 on 10? 2 minus a tenth. One and 9/10. 19 pi on 10. So you got 11 pi on 10, 19 pi on 10.